Yeah. Good morning, everyone. We're going to go ahead and start this briefing about the 2024 State of the Cryosphere Report. I'm going to be preparing as best I can. Please let me know if you can't hear me, since we're not using any sort of equipment to project sound, but this is also being recorded and live streamed. My name is Sam Pearson. I'm the director of the International Climate Initiative. These reports began in 2021 because of the very rapid changes occurring in cryosphere and the implications, especially observations and projections of what will happen in cryosphere at higher temperatures is changing very, very quickly. These changes have implications of mitigation and vision and urgency, in other words, timing, because the dynamics primarily are set by temperature for adaptation and damage. And I'll come back to those later on. But first, I'll turn it over to Dr. James Coker, who is the chief scientist for the Ambition of ministers will be meeting. We have the report available online. I'll turn it over to James to summarize some of the
Good morning, everyone. So, let's get started. It's not been a good year. These are just headlines that have been. So we're seeing accelerated melting events of the planet. Now, the reason why so many of these impacts are anywhere else in the world. We've warmed the Earth by about 1.3 degrees. But if we compare this to changes global average, so this means that we're already heating the cryosphere with temperatures that are already 2 or 3 degrees more than they were in the 1980s. So I'm going to go through each of our 5 dynamics here. You can see on the top list. So the year started off with mountain glaciers and snow. And 2024 saw a widespread decrease in the duration of snow cover by up to 30% in some cases in Asia, particularly in the western Himalaya region. Contribution to water resources is the largest. The impacts are felt acutely on the ground. So this photo from Namche, mountain, and a personal friend of mine, who cryosphere scientist in this region, and is actually the grandson of the last surviving member of the party which first scaled Everest, went home for the first time in a few weeks. And he was asked again and again by his neighbors for decades, why is our mountain black for the first time in living memory? Now, a few months later, the village of Tame, which is up towards Everest, was ripped through by a glacial lake outburst. This is a shock which is quite typical on the route to Everest. Homes, schools, hotels were just rapidly washed away. And look at the destruction. These boulders are the size of houses. Research published this year shows that 10 million people globally are now at risk of these catastrophic glacial lake outburst flood events. And the risk of these events is tripled by 2100, with the peak reached by 2050. Now, one of the biggest stories of the year this year came from Venezuela, which became one of the first countries in modern history to lose all of its glaciers. So the Andes have now deglaciated by 25% overall, and tropical glaciers in the Andes are losing ice 10 times faster than their long-term average currently. Now, when the final results for last year were in, the WMO was able to confirm that 2023 saw record glacial melt globally, with extreme losses, particularly in North America and Europe. Now, we measure the loss of ice on glaciers by drilling a stake through the ice, and it's very simple. We wait until the melt of the next year, and the height change in that stake is the ice loss for that year. Now, what you see on the screen is a guy called Matthias Huss. He's about as tall as me. And the stake there is the mean annual loss between 1950 and 1990. Every year you'd lose about this much ice. In 2022, we lost this much. In 2023, we lost this much. And this year, we've lost this much. So Switzerland has now lost 10% of its total glacier volume between 2022 and 2023. So we're seeing enormous accelerated losses in this region. Now, moving on to ice sheets, we have two of these on Earth, and they're absolutely enormous. So I've overlaid a map of Europe on Antarctica here for you. So those of you who are from Europe, I challenge you to find your country on that map, look at the scale difference, and then imagine your country being covered by a sheet of ice that's up to 4 kilometers thick in places. That gives you an idea about how much ice is actually held in these ice sheets. Now they're changing fast. So these videos show the amount of ice, the loss that has occurred over the last 3 decades. Red is bad here. So the rate of ice loss in Greenland is now 5 times higher and 25% higher in Antarctica than it was in the early 1990s. Now, because these ice losses are accelerating, we're now seeing that sea levels are rising twice as fast as they were 30 years ago. And this is having very big impacts today. So we can all remember the devastating hurricanes that have hit the US coast in recent weeks. And this is now directly caused by the fossil fuel pollution that we've been pumping into the atmosphere for decades now. It's costing lives, vast sums of money, and also just generally damaging and causing these extreme events to become more frequent and more damaging. The science of this is getting stronger now, so we can now show that the sea level rise we've already had to date, which is about 23 centimeters so far, is adding billions of dollars onto the cost of individual storms. So in the example of Hurricane Sandy, that extra sea level rise, that 23 centimeters, made the difference between Lower Manhattan being flooded. Now, it's not surprising that we're looking at these rapid changes, because in the past we have more and more evidence now that the ice sheets went from looking like this to like this at similar levels of warming to today. And scientists are still working out exactly how long that took to happen, but it shows the extreme risk that we are now taking by keeping emissions of CO2 this high for this long. And this is really why we have to lower those emissions as quickly as possible. This year has also generated a lot of new science understanding where and how the damage to these ice sheets is undertaking. And a very large model comparison that was published a couple of months ago showed that high emissions will lead to a massive acceleration in Antarctic sea level rise contribution in the coming centuries. And this really supports this massive difference you see on the right. The IPCC first pulled up in AR6. We're talking a difference between 1 or 3 meters by 2300 with low emissions, or potentially 6, 7, or even more under high emissions. Now, moving on to sea ice, which is a critical part of the Earth system, and it reflects a lot of that solar radiation and heat back out to space again and cools the planet. A paper this year showed that the decline of sea ice globally has now reduced that planetary cooling effect by about 14% since the 1980s. Which essentially means that the warmth coming in from the sun isn't going back out again. It's being brought in, absorbed, and creating more damage. Now, over time, we have seen a long-term decline in Arctic sea ice on the top, whilst Antarctica has recently appeared to have shifted into a different regime of loss in recent years. Last year set a new record for Antarctic sea ice loss, and the pattern this year has been maintained. So this may well show that we're now seeing a state change in Antarctic sea ice at just 1.2 degrees warming. So what's the outlook for the future for sea ice? We've got a choice here. So the top row of this diagram shows a future of the Arctic under very low emissions, one where at least some sea ice can be maintained all year round consistently well after the turn of this century. But now if I show you the moderate or high emission scenarios, the Arctic will become consistently ice-free for many months of the year, possibly within the next few decades. Moving on to permafrost, a comprehensive study showed that the estimate of the effect of greenhouse gas emissions from permafrost thaw in the boreal Arctic is now a net source of greenhouse gas emissions. This is new this year. Permafrost emissions will increase as temperatures continue to rise, and they will stay that way for centuries. Another study released this year showed that permafrost thaw responds essentially linearly to warming, so there's no safety margin beyond which this becomes a problem. Every tenth of a degree matters for permafrost thaw and will increase greenhouse gas emissions and warming every single fraction of warming. We also saw updates about subsea permafrost, and the future of this is directly tied to our global emissions trajectory. So with rapid emissions reductions, we can minimize losses of this subsurface permafrost to about 20% in the long term. But under high emissions, our current pathway, self-reinforcing feedbacks and vicious amplifying cycles will kick in, and this will cause rapid acceleration within the next 60 years. And this change will be irreversible and will last for centuries. Finally, polar oceans. The threat of acidification is mounting, with CO2 concentrations topping over 428 parts per million several times this year. Again, we are faced with a very stark choice. Either the permanent damage of the polar oceans under current emissions, or the choice to limit warming rapidly now with stringent mitigation. We're seeing growing evidence of acidification in the polar regions, which is damage that will then last for tens of thousands of years. This will have a direct economic impact on industries such as fishing and food production. And also we're seeing a number of alarming studies published this year, which indicate that there are major changes to ocean circulation beginning to kick off now. In Antarctica, the volume of cold, dense water produced in the Weddell Sea has already declined by a third since 1992, whilst increasing meltwater discharge in the oceans around Antarctica is meant to slow down ocean circulation by about 40% by 2050. This will then drive more warm water up to the grounding zone of the ice sheet, which can accelerate losses and increase this in another vicious amplifying cycle. A very prominent group of scientists, including Stefan Rahmstorf, who is one of the world's leading authorities on ocean circulation, in particular AMOC. He's now pictured on the right, presenting a letter to the Nordic Council of Ministers a couple of months ago. This is the Icelandic Prime Minister on the right, on the left, sorry. And in this letter, they argued the scientific advancements over the last couple of years show that major changes to Atlantic Ocean circulation have been greatly underestimated. So we need more research to understand this risk, but it's one which has really been overlooked in recent years by politicians and policymakers. And now I'm going to turn over to Pam to summarize three main scenarios we have in terms of warming in the report.
Thank you so much, James. As you said, in the report, and as you can say also in what we call the Toblerones, because they're three-sided, we focus on three possible futures for cryosphere and therefore for the planet. We look at the current climate commitments, which we have used the Climate Action Tracker as about an average between conditional and unconditional NDCs. That would result in an amount of warming of about 2.3 degrees by 2100. If current rise in CO2 continues, and that is the only thing that really matters, the amount of CO2 in the atmosphere, and that would lead to about 3 to 3.5 degrees of warming by the end of this century. So that is another projection, which is way above what the cryosphere can take. And then with immediate and rapid course correction, with 2025 NDCs, and we frankly need revisions of the NDCs that were put forward in Glasgow in 2021 to make them more 1.5 consistent, but that is still possible according to IPCC scientists, but it really is going to require a lot of effort and action. With that, we can see a very different future where much more of cryosphere is preserved for the long term and for things that we cannot stop right now, such as probably parts of the Antarctic ice sheet in particular, we can at least slow it down to a great degree. And when it comes to things like glaciers, they can survive to some degree. So we split this into the report in terms of ice sheets and sea level rise. I will summarize very quickly, but this is in greater detail. Current NDCs over time would lead to loss of very large amounts of both the Greenland and Antarctic ice sheets. If we stay, especially at that level for very long, Greenland, probably its so-called tipping point is more around 1.5, 1.6 degrees over time. Certainly 2.3 degrees over centuries would lead to complete or near complete loss of the ice sheet, 6 meters of sea level rise. Add on top of that, perhaps 10 to 15 meters from Antarctica. You can do the math, we're into 20 plus meters of sea level rise. But that massive sea level rise would occur much more quickly if the current rise in CO2 continues. We're not quite sure where that speed up will begin, but certainly anything above 3 degrees would lead to much more rapid loss from West Antarctica in particular, as well as portions of East Antarctica. When it comes to mountain glaciers and snowpack, very, very sensitive to the gradient between 1 and 2 degrees. Even 1.5 degrees is not enough to save the ice in many mountain glaciers, especially in the mid-latitudes and in the tropical regions. One of the findings of the report was, of course, the loss of Venezuela's last glacier. Indonesia is not very far behind. That will be the last tropical glacier of Asia. But if the current rise continues, most of the ice in mid-latitude glaciers will eventually be lost. Massive losses even in the Hindu Kush Himalaya. But here again, at 3 degrees, probably by 3 degrees, there will be almost no ice left in glaciers outside of the poles and very, very high altitude regions in the HKH and maybe in the Andes. But here again, 1.5 will lead to perhaps even some recovery of some mid-latitude glaciers, especially in the Alps. That's what the latest projections show. When it comes to sea ice, anything above about 1.7 degrees will show complete loss of summer sea ice for at least a few days or a few weeks each summer. Only 1.5 will lead to some summer sea ice some years. By the time you're over 2 degrees, you may be looking at complete loss of summer sea ice in the Arctic for a period that may range from July to October. The feedbacks globally from that would be massive. And of course, by 3 degrees, you may even be looking at an Arctic that is ice-free almost all of the year. You might get a thin skin of ice on top when the sun goes down. It's very cold still, but that ice will disperse very rapidly as soon as the sun comes up. And so that has great importance for permafrost feedbacks, for overall global warming, and also for loss of the Greenland ice sheet. Antarctica is a little bit more uncertain, but probably at these higher temperatures, there would be very little sea ice. For permafrost, as James was saying, there are no levels. It's been thawing for decades now. It will continue to thaw. It is very, very sensitive to temperature rises and even temperature peaks. But the message about permafrost is that those emissions, they continue for a couple of centuries. So even if humanity manages to bring its emissions down to zero, we would have to offset permafrost emissions. And the amount of emissions will simply be set by whatever peak temperature we reach. And in the report, you can see that certainly if we're up to about 3 or 4 degrees, they will be on the scale of, say, a major emitter like China or the United States today for the next 200 years or so. That would be a massive burden that we're placing on for future generations. And finally, for polar oceans, this is actually the least reversible of the dynamics we talk about. It takes 30 to 50,000 years for acidification in the polar oceans, which are absorbing CO2 much more quickly than the other world's oceans, to buffer out completely. And so that also is set solely by the amount of CO2 in the atmosphere. It's absorbed very quickly into the water. It disperses into the water column. And these are really non-survivable levels of acidification. We haven't seen these levels of CO2 in the atmosphere for about 3 million years. We're beginning to approach levels that resulted in a mass extinction in the world's oceans many millions of years ago. So really, this is the one that gets the least attention in many ways. Perhaps it should have the most because of the implications for food supply, world fisheries, let alone biodiversity, and what was concluded in Cali a couple of weeks ago at COP16, the biodiversity COP. So with that, 5 basic messages. We cannot negotiate, of course, with the melting point of ice. That is 0. Some losses are now locked in, and we will need to adapt at some level. We can still choose, however, what the future is going to look like by rapid decarbonization. But at one point, we move beyond limits of adaptation, and loss and damage then from non-reversible cryosphere impacts globally become locked in. And we have really, you could say, 5 years to course correct. 1.5 really must be considered a red line because of the cryosphere. I do want to say, though, and this is important, every fraction of a degree counts. If there is a conclusion, as we suspect, that this year was actually 1.5, every bit of a degree for every number of years is going to be important to slow down these processes. It's not that we throw in the towel. So with that, I wanted to turn it over to questions and introduce some of the scientists who were authors and reviewers on this year's report. So going from my immediate left, we have Dr. Regina Hawk, who is at the University of Oslo and was an IPCC SROC author, the Special Report on Oceans and Cryosphere in a Changing Climate. Dr. Heidi Silvestre, who is a Deputy Director of AMAP, a working group of the Arctic Council, who is a general, I would say, Arctic expert, alpine expert, also on permafrost in the Arctic. To her left, Dr. Miriam Jackson, who until recently was working with the Pan-Himalayan organization ICIMOD, also an IPCC SROC author in mountain glaciers and snowpack. Dr. Robbie Mallet, who is at the Arctic University of Norway in Tromsø, Norway, a sea ice expert. He actually spent an Antarctic winter down studying sea ice in Antarctica, as well as being an Arctic sea ice expert. And finally, Dr. Chris Stokes, Durham University, ice sheet experts, also glaciers, and so he can take particularly questions. I would say he published a paper just a couple of years ago on East Antarctica and potential rapid loss of ice there. So with that, we can open it up for any questions. Everyone will be available for interviews afterwards. Yes, please.
Good morning. This is Ferdinando Coutinho from Domani, Italy. And how, to James and everyone, how does it feel to bring such urgent news in these topics? Fossil country, you mentioned fossil fuels, and
I mean, it's not the first time we're making this message. It's been said again and again and again for years now. But time is really melting away in terms of time for action here. And so we'll keep talking louder and louder. The impacts will keep growing and growing, and hopefully someone will eventually listen. But really, the long-term impacts of these choices are being made by policies now. So we've got, as Pam said, about 5 years or so to really course correct this, to prevent a lot of this really, really bad stuff from happening for a very long time, for multiple generations.
This is a very general question. 29 years going forward, are we losing the fight? Are we lost the fight? But if you look at the graph, it looks like with all the medications, suggestions, what we're trying to, achieve, we don't see any impact of what's going on. Because it seems to look at ice melt. Have we lost the fight?
Okay. So
are we losing it? Or we have lost it?
Thank you. So the question is, have we lost the fight?
Yeah.
Do you want to start with that one? We'll take that one.
Well, I mean, I can take a start. Are we losing the fight? Of course. because for every year that goes by, we see more and more changes, but we have not lost it, but we are losing portions of it. And that's, you may hear, if anyone wants to talk about tipping points, in many ways, cryosphere scientists don't like to talk about tipping points because there's not one. There are many tipping points. We are passing them. And when I say every glacier, as Regina and Miriam can tell you, every glacier has its own tipping point. Every portion of Antarctica has its own tipping point. Every meter of permafrost has its own tipping point. So the more we can hold it down, the more we can make these changes less and less. But we are in the process of losing it for every day that goes by. Yes.
I mean, said the fact that it's not slowing down, it is.
Unfortunately, yes, CO2 emission, or let me put it, CO2 concentrations in the atmosphere probably had a record rise this year. Now, that probably is due to warmer oceans not absorbing CO2 as quickly. That's one reason why the polar oceans are having so many problems. Cold water absorbs more quickly. But, it is not slowing down. The rise of CO2 is not yet.
So can I do a little politics here?
Very quickly, because we have
now
other people's questions.
We have a climate, denial that has emerged.
Yeah.
If our friends in America decide to move by that policy, what is going to happen? Climate denial. Trump is now the president of America, and we know what he stands for as far as climate change is concerned.
So I'm actually from the US as well as Sweden, and so I can say that yes, the federal government will not be acting, but what happened actually and did not get as much attention during the first Trump administration is that states continued, and many of those states are very large economies. California, if it were a nation, would be the 6th largest actually economy in the world. And those states are still committed to addressing climate change. Many of the states that are climate deniers, and unfortunately, they are very susceptible to things like sea level rise, Alabama, Mississippi, very low GDP states in many ways, very low emitters on their own, are the ones that are going to suffer from climate change. And as we say, you can't negotiate with the melting point of ice. That will happen. So we would place our hope on subnationals to make things keep on going. More questions, please. Yeah, please.
Yes, George from European Space Agency. Working on commissions and architecture. I'm generally interested in building wise frameworks to ensure that the remote sensing infrastructure is ready, provide information evidence base for effective work. We're not speaking it. So my question is kind of threefold. First, before we get started on how close you are to transgressing the pretty nice way to waste if you want to get everyone's space, do you need what additional measurements do you need? And the third is the Earth system governance community who are looking to try and find mechanisms to bring all the data into governance.
Yeah, Chris, do you want to take that?
I can take the first question.
Yeah.
There's a lot of science at the moment looking at potential tipping points for Greenland and West Antarctica. There are some people who've published papers saying that we've already passed the tipping point in West Antarctic ice sheet. You have to remember as well, if we have, we probably won't know and realize for a few more decades. Yeah. Greenland, we used to think the tipping point was about 3 degrees of warming, then it came down to 1.7. Now it's come down to about 1.5. But there are some people who think that parts of the Greenland ice sheet have already crossed that tipping point. So I say this a lot when I give talks about ice sheets. They exhibit very non-linear behavior. So we're walking towards the edge of a cliff very slowly, and before we know it, we'll drop off the edge of the cliff, and we'll be falling through the air, wondering what's going on, but it'll be too late then. So we must adopt this precautionary principle and ensure that we limit warming as much as possible to avoid crossing those tipping points. Because there is some uncertainty exactly where they are, but they're very, very close. Somebody else might want to take the other questions.
My name is Bhupa. I'm representing Tibet Plateau. So since we are talking about the cryosphere here, I think the Tibetan Plateau is somehow missing here. We have talked about the polars, the Greenland, the melting of the ice sheet. Tibetan Plateau has a lot of glaciers, okay, great rivers that comes through the Asia. So don't you think that we can send a scientific survey or anything that can help the cryosphere to restore in Tibetan Plateau if there's some problem in rivers or whatever, it can affect the downstream communities as well. So don't you think that
Can you repeat the question?
Can you repeat the question before you
there's
answer?
a huge glacier, so
I can take that question. So until about a few weeks
A lot
ago,
louder, Miriam, so they talk to those people in the
until
back.
a few weeks ago, I was working at Isimod, which is based in Kathmandu, but we're working in 8 different countries. And so China is one of them, and also Nepal and Pakistan and India and countries adjacent to Tibetan Plateau as well. And we're seeing, as was mentioned previously, that the temperature increase is a lot higher in the Hindu Kush Himalaya than the global average. The temperature increase is twice as high in the whole of the Hindu Kush Himalaya, but obviously it's faster in some places than others. And there's a lot of things going on there. One is there's a lot of permafrost, which is frozen ground on the Tibetan Plateau. That's going to give off emissions as well, not as much as the Arctic, because it's not as big, but still a huge area. And also there's a lot of construction at high elevation. There's a lot of people, there's roads there, there's developments, hydropower, houses, or people living below. They're going to be affected by permafrost degradation. And you mentioned glaciers. This is a huge thing because a lot of the glaciers are quite small. You look at them compared with Greenland ice sheet, they're nothing. But you could have thousands of people dependent on water from a very small glacier, group of glaciers. So we see the glaciers in this area are changing very fast. We see there's millions of people downstream dependent on them. And the governments in this area really need to take action because the water resources are changing. What happens when the glacier melts? Water increases for a while and then it decreases. So there's several things you have to adapt to. So you need to get a message to the policymakers in the region as well as globally that the glaciers are changing fast. It's going to affect not just the people living close to glaciers, but the hundreds of millions of people living downstream are all going to be affected.
Yeah.
So I have a question.
Yeah.
I have a question on the definition the angle and the fact that the region is now that source of the emission. This potentially be the two biggest phenomenon and behind also currently happening with the angle. I don't know if it's important, but right now it's the most pressing issue. And how is this related to the conflict?
You want to try that?
Yes, there's two parts of the question here. So permafrost is definitely to aim up, but that is a net source now from the boreal forest in the Arctic. As Pam said, that is already emitting greenhouse gases. Now it's a net source, so it is contributing more than it takes down. So this is definitely a problem. AMOC is still in the balance, I think, but we are seeing changes to ocean circulation both in the North Atlantic and in Antarctica. How close we're getting to some sort of tipping point is still not well known, but it's a massive danger. So anyone in Northern Europe is seriously worried about the possibility of that happening.
And again, just to clarify, I don't know if Heidi might want to comment on some of this. So in other words, what's called the country of permafrost, right? It also greens up every summer. So it absorbs carbon dioxide. But as the permafrost thaw, it is emitting carbon dioxide and methane and a little bit of nitrous oxide as well, which is a very powerful warmer. And that's been hopefully in balance or even in net sync. But what permafrost scientists have said, in other words, is that the amount that's being absorbed by this region of the planet is no longer enough to offset what is being emitted by thawed permafrost. So that might be one of the things contributing to the increase of methane in the atmosphere. That's called wetlands, but what is really going on in many of those cases is you have permafrost underneath the wetlands that is thawing and emitting. And whenever you have permafrost thaw in wet conditions, it comes out as more methane than carbon dioxide. Heidi, do you want to say more on
Yeah, I
that?
just want to add something about the importance of permafrost in the northern parts of the world. Actually, some of our reports from the Arctic Monitoring and Assessment Program have shown that 66% of the infrastructure in the Arctic regions is built on permafrost. 66%. There are about 7 million people living in the Arctic, so you can understand permafrost matters for the entirety of the planet, but it also matters tremendously for the people who live there. And also, I'm sure you've heard, but the more permafrost stores, the more we might have bacteria, viruses, microbes, of course, coming out of permafrost, and this could also directly impact communities living in the Arctic. So yeah, permafrost matters tremendously, and the best permafrost we have is the permafrost that remains frozen.
I've asked for the financial instruments, so in addition to the climate mitigation, in the next 5 years, what will be the most immediate actions to reduce loss and damage for the non-significant but also downstream? And take like 3 actions. Everyone.
Well, one action for everyone is the obvious one. We really need to cut emissions. This is something everyone needs to do, and it affects everybody as well, so it's worth doing. Also, that we need more information about it because there's very little information about the cryosphere in high mountain Asia, and especially in the Hindu Kush Himalaya. I know there's a lot of work in China, quite a bit in India, but outside those countries, we know very little. So we know the glaciers are changing fast, and we have to also start telling people downstream that they need to adapt to it. But this is being done in different ways. In Pakistan, you have a big Block 2 project where they're, for example, building Gabion walls, where we think there's going to be glacial lake outburst floods. We need to make sure that people know that the water resources are changing. There's a lot of very dry areas, for example, in Gilgit-Baltistan, where it's like a desert almost. And then where you have the snow and glacier runoff, it's like these oases where you can grow a lot of food and where people live. And we also, there's the example given here of the small glacial lake outburst flood in Nepal recently. It came from a very small lake. It wasn't one of the ones that had been identified as being a problem. That's because it was so small. And actually, it didn't kill anyone, but it caused a lot of damage. I think it's, wiped away a couple of schools and health posts, a lot of housing, a lot of economic loss. So even these very small lakes that we can't keep an eye on, so keep an eye on the big ones, they can also cause a lot of damage. So we need to make people aware that even if we haven't said, this is a problem in your area, that there's so many problems, we can't identify them all. And we have to be ready to adapt to changing water resources, either more water or less water or in succession, and also possibility of floods. So, for example, by glacial lakes or even intense flooding smoke, this kind of thing.
Any more questions for the scientists in particular? Okay, thank you. We're all available, except for James, who needs to rush off for an interview. But so if you want him, you need to act quickly. And we'll be here for at least another 15 minutes if you want to speak to us. Thank you for coming to this press briefing. And please have a good day at this very interesting 24 hours with the World Climate Leaders Action Summit. So thank you so much. And thank you for the scientists.